Welcome to the CMA CGM Hugo. Short name, but humongous ship. You're looking at one of the largest container ships in the world. She's longer than 3 football fields and 30 feet wider than the Suez Canal. Unbelievable. And holds enough cargo to stock the shelves of a 1 million square foot shopping center. The CMA CGM Hugo is a mighty monstrosity welded together out of thick sheets of high-strength steel. What I find fascinating, even magical about these huge ships is this. If I toss a steel nail into the ocean, you know what happens, it sinks to the bottom. And yet, here I am standing on a ship made of 60 million pounds of steel, and it's floating. Now, as a physicist, I understand why, of course, but that's not the point. The point is that it's all very counterintuitive, which means that someone somewhere along the line had to figure it out, had to figure out that steel floats. Who was that someone? Archimedes. Again, he was the brain of his time. He invented weapons, pumps, compound pulleys, but what he's most remembered for is his historic discovery about buoyancy, the so-called Archimedes principle. Even if you're not a scientist, chances are you've heard of Archimedes' principle. It's such a simple yet profound truth that it's taught in grade schools all over the world. Simply stated, it's this: any floating object will always displace its own weight in water. What Archimedes also proved is that the size and shape of a ship's hull makes a crucial difference in how much cargo it can carry. But you know what? Hearing it stated isn't nearly as much fun as seeing it in action, so follow me. Welcome to the Where Did It Come From workshop. Now, you can see I have my basic setup here. This is the ocean, my fish tank, and here are 2 ships. There's a small one, and if everything is going right, they should be about the same weight. So that one weighs in at about 2.5 pounds. Let's see this other one. 2.5 pounds. All right. So if Archimedes' principle is to be believed, the only thing that matters here is the weight. I'm going to put the first ship in here, and as you can see, the water level rises right up to that top black line. All right, super. Now let's look at the smaller boat, same weight, and if Archimedes' principle is to be believed, when I put this in here, it should raise the level of the water right up to the same mark, and there it is. So there's Archimedes' principle, but Archimedes didn't stop there. So much for the buoyancy of ships. He also made a very interesting discovery about the cargo capacity of ships. Let me put this big one back into the water, and watch what happens when I try to load it down. Now I have some shot here, small washers, a whole cupful, which I'm going to distribute evenly into this ship. And let's see if it can hold this without sinking. And sure enough, it does. It just floats. So let me take this out, and let's check it out with the smaller boat. All right? Again, same weight, different shape and size. Let's see if that matters. Okay, I've got another cup of weights, of washers, identical to the first. Let's do exactly what I did a moment ago with the large ship. Got to just make sure it's distributed evenly so it doesn't get tilted one way or the other. Didn't even make half the cup. So here is the perfect example of what Archimedes discovered. If you get just the right shape and just the right size of ship, even if it's metal, it can have a huge cargo capacity, like this one. Knowing all that, Archimedes didn't hesitate a moment to clad the Syracusia's hull in sheets of lead in order to keep the seawater out of the gigantic ship's hold. A seemingly crazy idea that kept the Syracusia high and dry.